Hello there, my name is Frank Ortiz, and today I'm here to talk about the law of sine and its real-world applications. The law of sine is a part of trigonometry which centers around the function sine and uses angles to find different lengths. Specifically, we are going to focus on the use of the law of sine on mechanical equipment such as cranes. The law of sine consists of three properties that are true. These properties are a relationship between the angle and the side across it in a triangle. Now, before applying the law of sine in a triangle, we must first be able to identify all three angles and the length of at least one side. Once you have determined these components, you then need to label a triangle. It is most common to label the angles of triangle as capital A, B, and C, and the sides as lowercase a, b, and c. The law of sine indicates that sine of a certain angle is always going to have a connection with the length across. For example, as you can see in this triangle, capital C, which is representing angle C, is directly across lowercase c, indicating that there is some kind of connection. Therefore, when putting it in equation form, all three components of the sine equation have to be equal. Here is an example of how the law of sine would be used in real life. Let's say some engineers are trying to construct a crane and they have the given angles 8 degrees, 40 degrees, and 132 degrees, along with the base, which is 20 feet. Our goal here is to find the lengths of C and B to determine how much metal should be used in order to construct the crane itself. In order to identify the sides of B and C, we first have to clear up the fact that 20 feet over sine 8 degrees is equal to B over sine of 40 degrees and is also equal to C over sine of 132 degrees. With this given, we are going to set up an equation. 20 feet over sine of 8 degrees is equal to B of sine of 40 degrees. In order to do this, we are going to multiply both sides by sine of 40. Once we multiply both sides of sine of 40, we're going to leave B by itself and the equation to it 20 feet times sine of 40 over sine of 8. This will give us approximately 92.37 feet, which is the length of B. Once the same process is repeated, we will get 106.8 feet for C. Now we can move on to the next part of the problem. In the second part of the problem, let's say that these engineers are trying to find the least amount of rope they must have so that it can hang down. In this case, that length will be E. In order to find this, we're going to first have to find capital E, which is the opposite angle from 132 degrees, in order to be able to go through the same process and find little e. Now first, we have to subtract 132 minus 180 degrees. This is because any flat line will always have 180 degrees. Therefore, 48, along with 132, creates 180 degrees. Now, in order to find little e, we are going to have to set it up the same way, with little e being this length over sine of 48 is equal to 92.37 feet over sine of 90 degrees. Now, in order to get little e by itself, we are going to have to multiply sine of 48 degrees by both sides. This will leave us with e equals sine of 48 degrees times 92.37 feet over 90 degrees. 90 degrees is gotten, because this is flat and this line is going straight up, this is going to be left on the side right here, right across or next to 48 degrees. Now, once this has been plugged in, we are going to get approximately 68.64 feet. And there you go. This is how the law of sine is used in real life manufacturing. These steps are very, very important because they create structure in different buildings and in the equipment used, ensuring that we have efficient vehicles and also strong support systems in many of the buildings that we go on our own daily commute.